to look at what is quantum computing and what is it used for in the current world today, because this is one of those technology that promises heaven for data processing, and I think this will go a long way in helping human and generally helping the community and the world at large in solving those hard problems that will take many years to solve because of the kind of the processing power that quantum computing possesses. So there are so many companies that are currently involved in various technological research in regards to quantum computing, because this is one of those technology that in the near future will be able to deliver a precise problem solving to general problems that we are facing in every sphere of our lives, like in medical, in data research, in computer security. So these are areas where quantum computings are going to play a lot of importance as far as making sure that technological advances are able to bring forth value for the humankind and possibly change the course of general understanding of technology. So I've been going through the internet trying to find out information. Then I came across this article done by Jake Frankenfield and reviewed by Doritha Clemon and fact-checked by Kristen Smith. So according to this post or this content, they're saying quantum computing is an area of computer science that uses the principle of quantum theory to explain the behavior of energy in material on the atomic and subatomic levels, because everything that exists today exists in atom, and so the only way to advance this technology is to understand how these subatomic particles such as electrons and photons are able to interact. Now, quantum computing uses subatomic principles such as electrons or photons to come up or to work out the problem or to solve the problem that exists. Now, quantum bits or qubits allow these particles to exist in more than one state at the same time. So it allows them to exist in more than one state at the same time, as compared to the classical computers, which only have data existing in one or zero state at the same time. So when you have element existing in more than one state, then you increase the chances of being fast and efficient. Now, qubits exploit the interference between their waves-like quantum state to perform calculations that otherwise would take many years to perform. Now, classical computers to now employ a stream of electrical impulses in binary manner to encode information in bits. Now, generally, this is able to limit or to restrict processing ability of a classical computer compared to the quantum computing or quantum computers. So we need to understand this so that we are able to wrap our head around this technology and become better in understanding the technologies that are basically evolving and developing around us. Now, understanding quantum computing. Now, the field of quantum computing emerged in 1980s. That is when the whole idea was suggested, and a few researchers here and there started working and developing the quantum computing that we have today. And they were able to find out that certain computational problems could be tackled more efficiently with quantum algorithm than with the classical algorithms based on the computers that we are using. Now, quantum computing has the ability to, churn huge number of data content in terms of numbers. It can sieve through huge numbers for possibilities and extract potential solution from those numbers. So where classical computers can only store information in bits, which is either a 0 or a 1, and as I mentioned earlier, using zeros or the two states that exist in classical computers limits the performance of the computer. But when you look at quantum computing in broader aspect, considering that a quantum computer solving a problems will have its data stored in qubits, which has got more than one state, then the chances of solving that problems becomes higher and fast. So now, classical computers store information as bits, which is either 0 or 1, but quantum computing uses qubits. Qubits can carry information in quantum state that engages 0 and 1 in multi-dimensional way. So it means that the data in this aspect is able to exist in more than one state. All right. So such massive computing potential, or such huge computing is able to attract many companies, and these companies have been able to put their weight behind the development and researches that are geared towards coming up with quantum computing systems which are able to solve the basic problems that probably we are facing today. Some of the companies include IBM, Microsoft, Google, D-Wave Systems, Alibaba, Nokia, Intel, Airbus. We have HP, we have Toshiba, we have Mitsubishi, SK Telecom, NEC, Raytheon, we have Lockheed Martin, Rigiti, we have Biogen, Volkswagen, and Amgen. So those are some of the companies that are trying their best to actually make it possible for quantum computing to have success and to be able to change the computing in the near future. All right. So those are some of the companies that are technically doing their best to make sure that we have best quantum computing technology at hand to sort our issues that range from computational to AI and many others. Now, looking at the uses and benefits of quantum computing, there are a lot of advantages and a lot of uses that can be derived from use of quantum computing. Now, quantum computing can immensely contribute in the security field, in finance field, in military affairs, and basically intelligence of a nation or security, and also in drug research and design. As we can remember, during the season when the world was going through a tough time owing to the effect of COVID, one of the technology that helped a lot in coming up with the vaccines because of the smart system that the researchers were using was the use of artificial intelligence in basically studying the trends and the morphology of COVID, and this helped a lot in coming up with the vaccine that normally take years to develop. So because of the smart systems that were used, the development of vaccine was fast, and technically we were able to get this vaccine in time. So those are some of the benefit, speedy solution to problems. So some of the areas where quantum computing is going to take center stage are like aerospace, drug design, utility areas like in nuclear fusion, polymer design, and machine learning. There is also the aspect of having quantum computing in artificial intelligence, big data research, and digital manufacturing. Now, quantum companies can be used to improve the secure sharing of information, or to improve radars and the ability to detect missiles and aircraft. So those are some of the areas where quantum computing is expected to advance the technology to a different level altogether. Now, also, when looking at the serenity and how the environment is supposed to operate, now quantum computing can be used with sensors to be able to study or be able to keep water and generally our environment devoid of chemical. So this can be able to make sure that human are able to breathe in and to use those quantity and elements that are free of chemicals, and this will go a long way as human beings will not get infection owing to the contaminated use of elements from the environment. So in regards to that, as I mentioned earlier, quantum computing promises heaven for humankind. So in regards to financial institution, quantum computing can be used to design effective and efficient investment portfolios for retails and institutional clients. Now, this could now direct attention to better trading simulation, and also can help in security by improving fraud detection, so that the financial system and institutions that are currently trading do not incur loss owing to a breach of security and fraud as far as they're concerned. Now, in medical care or industry, quantum computing can be used to develop drugs and genetically targeted medical care. Now, this could help us solve advanced or have advanced DNA researches that are able to, be able to find out more about the DNA configuration and structure, and this will go a long way in coming up with medical and medicine that are able to help us at the end of the day. Now, as far as online security is concerned, quantum computing promises to design better encryptions and ways to use light signals to detect intruders in the system. So these are just some of the areas where we will be able to see quantum computing taking center stage and bringing forth the best out of the systems that we already have at our disposal. All right. So quantum computing can also be used to design more efficient, safer aircraft and traffic planning system, because that is where the world is going. Because at the end of the day, human discoveries have always been geared towards solving the general problems the humans have, and in some instances the solutions have been there, but sometimes these the aftermaths are dire and cause problems. But with quantum computing, we'll be able to have safer aircraft. We'll also have a traffic planning system that can be able to control traffic within a city. Now, there's some basic or fundamental of quantum computing, and we need to look at some of them. Now, there is what we call superposition, there is what we call entanglement, there is what we call predictable and decoherence. So those are the major features of quantum computing. Now, we have two major features of quantum computing, and these are superposition and entanglement. Now, these are basically well explained by researchers, especially in the field of physics. So quantum computing is squarely based on these two technology. Now, superposition is basically what quantum beings can do, rather than what it is that remarkable. Now, a qubit places quantum information that it contains into a state of superposition. So a qubit places quantum information that it contains into a state of superposition. This basically refers to combination of all possible configuration of the qubits. Now, groups of qubits in superposition can create complex multi-dimensional computational space. Now, that is what we call superposition. That the qubits can exist in more than one position. So they can exist in multi-dimensional position, and this one is able to help increase the possibility of solving problems very fast and in different ways. So that's why we are told it is what qubits can do rather than what it is that is remarkable. Okay, so apart from superposition, we also have entanglement. So entanglement is integral to quantum computing power. So pairs of qubits can be made to become entangled, okay, or pairs of qubits can be entangled. This means the two qubits can then exist in a single state. Now, in such a state, changing one qubit directly affect the other in a certain manner. Okay, so that is very important. So it is. So these are some of the main components of what we call quantum computing. So the features of quantum computing is superposition, the ability of qubits existing in multi-dimensional position. Then we also have entanglement, where we can have pairs of qubits being entangled, and thereafter, if you make any change or if you affect one of the state, so that one will technically affect the other qubit, okay, because they exist in pairs. So normally when this is during or in entanglement, changing one qubit directly affect the other in a manner that is predictable, okay, and also you see quantum algorithms are basically designed to take advantage of this relationship to solve problems. So to take the advantage of entanglement, to take the advantage of superposition, so these algorithms are far much efficient as compared to the classical algorithm that we have here. And now this one is able to double the power of processing because it is able to solve problems exponentially as compared to the classical computers that we have. Now there is also what we call decoherence. Now decoherence occurs when the quantum behavior qubits decays. So the quantum state can be disturbed instantly by vibration or temperature changes. This can cause qubits to fall out of superposition and cause error to appear in computing. So in as much as we are talking of quantum computing being able to bring forth data processing at a higher speed than never before, we also need to contend with the environment with which these systems are able to function, because they require a serene kind of environment where there is no disturbance, and the devices must be, the temperature must be as very low, so that the whole idea of superposition and entanglement are able to exist and sort our problems. So decoherence occurs when the quantum behavior of qubits decay. Now the quantum state can be disturbed instantly by temperature and vibration. So that's why we are looking at a quantum cooling system, which are far much advanced than the ones that we have for our classical computers. You see, our classical computers, like the ones we're using today, are designed in such a way that you have your computer with a fan that is able to cool the system. But with quantum computing, we'll need things like super refrigerators to even vacuum chambers to be able to help cool the system. So those are reasons why we are still doing a lot of research in as far as quantum computing is concerned. There's also the limitation of quantum computing. All right. So we have things like decoherence or decay, which can cause destabilization of qubits in their operating environment. So we also have problems, in error detection of computing elements. The error detections are not as advanced as they should be. So we have problems with error detecting. So this can affect the results of computation in quantum computing. Now, retrieving computational result can corrupt data. So that is another area where quantum computing is having some sort of limitation. So development of such particular databases, such algorithm can ensure the act of measuring will cause the quantum state to decohere into correct answer. Basically holds some promises, but retrieving computational results can corrupt data in quantum computing, and that one is something that is also being worked on, being researched on currently. So we also have security, and quantum cryptography is not yet fully developed. So those are some of the limitations. Then lack of qubit prevent quantum computers from living up to their potential for having a better performance at the end of the day, reliable performance, to be precise. So it is important to know that in as much as we have all these technologies that are promising a lot to us, there is still much that needs to be done in terms of studying of these components of quantum bits and how to preserve it to achieve its purpose when it is functional. So the research is going on, people are studying, and also as people who have stake in this, and those people who are enthusiastic about technology, we should play our role as making sure that we study all these researches that are coming and be able to also weigh in. You never know, you can be able to have an idea that can be able to transform and change the face of computers today. So this is very important to study this, and I hope this information is able to help you basically understand what quantum computing is, its advantages and its limitation, and how it can have a great impact when it is fully researched and fully implemented. Even though there are a number of researchers, philosophers, and thinkers who are who have divergent views as far as this is concerned. But at the end of the day, all this critiquing, analysis and deeper studying of these elements are very important, because they play a role in making sure that the systems we get are according to the standard, and they are able to fully provide that which they have been designed for. So thank you